today. I'm Kai from Social Finance, and I just wanted to walk you through some concepts we're currently working on. What I'm going to show today deals with a very specific problem, but one that's very common. There's a lot of really interesting analysis done by this community. However, it is difficult to share and replicate. Due to the very sensitive nature of the data we work with, we have to be very careful when we do analysis to not accidentally share identifying outputs. This means that there is often a significant obstacle when it comes to sharing code behind an interesting piece of analysis. The overall aim of this project is to have a directory, one can even call it an app store, of data analysis that can be run without needing to install software or understanding too much of coding, or any coding, to be honest, but can still be delivered to the end user without having to sign a data sharing agreement and set up servers and all of that. We also want this community to be able to share the best pieces of work, but without having to learn JavaScript or any advanced coding concepts. We recognize that when doing data exploration, you need to work with real-world data to understand the constraints and the possibility. We therefore want the app development process to be as close to the data exploration as possible. It should also be very easy to add features, and let's admit, squash those pesky bugs. We all write them. In this presentation, I'm going to focus on that last phase. How do we turn an interesting chart into a distributable app? I'm going to start with a Jupyter notebook, here shown running in Jupyter Lite, so running entirely with the browser. So it's safe to upload personal data into this environment because it never leaves your working computer. To get started, we can ignore the bit at the top here. That's just me pulling in the libraries from this pre-release version. We do our standard imports, and we want to start by declaring something to plot. Here I just create a polynomial function. It's just to have something to show. Normally, you'd probably instead, this is where you would load some data and tweak and manipulate some data. We then kind of just, well, first of all, let's test our polynomial function with a couple of values just to see that it actually works. We need to get some sensible outputs out of this, obviously. Polynomial function takes a value of x and then is the three coefficients and just calculates the values. We can try that for a different value of x as well, just to make sure that it changes, which it does. That's perfect. So we just want to see how this changes. First thing we do is we declare a range of x values to plot. So from -10 to 10, that's great, but we can't actually pass range, the generator, into the plotting library. So we instead create just a tuple of those values. Secondly, we create our y values, which is recalling our polynomial function for each of those values of x, passing in our a, b's, and c's. That then gives us a similar list of values for y. Now we have effectively everything we're going to plot. This would be the data series that you plot based on the data. We're now going to use matplotlib, but we plan to support different libraries as well, so several different libraries, but in this case we just create a standard matplotlib figure. We add our axis to it, and then we plot the x's and y's on that axis, and here we can go. That's pretty much what we'd expect to see. Now that we have our working figure, we need to package it up as an app. So we're going to turn our inline code just into a function. We declare a little function called plotme. We just move all of it in, and we add a return statement where we return the figure because that's what we actually want to plot. Just to test this, we can type it in, give it values for A, B, and C, and just make sure that it works. There we go. There's a little curiosity here that it's actually returning twice, and that's because Jupyter will plot it inline as well as, of course, it plots the return value, which is the figure. We can see here we can plot that separately as well. Now we have all the parts we need to build our application, which is basically the Python code required to draw the charts we want. What we need now is to tell the patch framework how to use the code we've written. So we declare something we call a view. So a view is a page. It's part of an application. You can imagine a view as, a different page in maybe a PowerPoint or even in a book, where you move from one to the other once you've finished the first. So in this case, we have a view, and we want to declare the three inputs that we need to use our functions. So our A, B's, and C's. We also add a little bit of explanatory text at the top. There's a paragraph. And then we have a submit button that will take us to the next page. For the next page, we'd like a chart view. That's a very simple view. It's only got one component, and that's the chart. And it's got the plot me function. We actually get a reference to the plot me function. So when you see plot me there, that's just the name of the function. We could have called it anything. We use plot me. We string all of that together in an app where you see we give it a name, doesn't really matter what the name is, and we pass it the two views, our input view and our chart view. Now, what is an app? An app is quite simply a bit of configuration that'll tell our final front end how to draw itself, the order to show things, how to show the components and so on. And this is just illustrative of what that configuration looks like. We're now going to output in a slightly more condensed format, just for the purpose of this demo. I can take that and copy it into our sample front-end code. But this is where, in real life, we would publish this to the App Store so that others could easily find it and use it without copying and pasting. And here we see what the actual application looks like. It's got our paragraph of text, it's got our 3 inputs, and our submit button. And there we go. That's a quick walkthrough of this sample application and how we imagine this might work, how to go from data exploration in Jupyter to a publishable app.